Okay, so we are starting Unit 8, which is talking about quadratic functions. So we're going to talk about a couple of vocabulary words first, the first one being a parabola. So this is a graph of a quadratic function. So all of the functions that we are going to be graphing in this unit are going to be quadratic functions. And instead of having a straight line, now they will make a U shape, kind of like the picture down below. A quadratic parent function is the simplest quadratic function. Just like what we had with linear function, we had a parent function, which was y equals x. So with a quadratic, the parent function is going to be y equals x squared. Then another feature of a quadratic is a vertex. This is the max, the maximum, or the minimum point on the graph of each function. So if it was right here of our graph, that would be the max. And if it was right here on our graph, that would be the min. So there's two different possibilities depending on which way your graph looks when you go to graph it. If it's the lowest point, it's the minimum. If it's the highest point, it's the maximum. Okay, a couple more vocabulary words. The axis of symmetry. This is the line that intersects the vertex. So it's going to cut straight through that highest or lowest point and divides the graph into two congruent halves that are reflective of each other. So if you fold that graph across that axis of symmetry, your graph would be perfectly symmetrical. So that is that line that they have right here in the middle of the graph that's in red. That is the axis of symmetry. And whenever you write your axis of symmetry, you're going to write it as x equals whatever number, just like what we would do when we would write an equation for a vertical line. X equals a Vux equation. And then there's two different ways to write a quadratic function. There's the standard form, which is y equals ax squared plus bx plus c. Or we have the vertex form, which we'll talk a little bit about in one of our sections. So let's go and graph some of these on the first example. So we want to graph the parent function of a parabola, y equals x squared. We're actually going to graph this in our calculators. Our calculators are able to graph for us. So the first thing we are going to hit on our calculator is the y equals. So that is in the upper left corner, right there, y equals. And we're going to type in x squared. So the x is the button to the right of your green button. It says X, T, and then it has a funny looking O and an N. If you hit that button, it will make an X for you. And then if you look down on that left column, there's a button that says X squared. This will put that exponent of 2 for you. So if you hit that button, it will put the little 2 for you, and we want to graph this. So in order to graph it and see what our parabola will look like, we're going to hit the graph button, and that is in your upper right-hand corner. On your calculator, it's a very small button. It's like a sliver. So when you hit that graph button, you're going to have a graph that looks like this. And yours is going to look probably a little different because you have a 10 by 10 graph. So yours may look a little different, but this is what your graph should look like when you hit the graph button. Now, it's not always super easy to see what points are on the graph in your calculator. So in order to get exact points, you're going to hit 2 buttons instead. You're going to hit your blue second button, which is right in underneath your y equals, and then you're going to hit that graph button again. When you do that, it's going to pull up a table. So this has all of those points that are on that graph forever and ever, and you can scroll up and down just like I am. So if you look at that, we're going to fill out our table. I like to start in the negatives and write down the first point that I possibly can graph on a 10 by 10. So I'm not able to graph -416, but I am able to graph -3, 9. So I'm going to put that on my table. -3, +9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and our last one is 3, 9 that will fit, and it happens to fill out our table perfectly in our notes. So now that we have all of those points, we can go to our graph and we can graph them. So -3, 9 we're going to graph, -2, 4, -1, 1, 0, 0, +1, 1, 2, 4, and 3, 9. And you can see that when you graph these points, it's going to make that perfect U shape that we know a quadratic is supposed to have. So connect all your dots once you have them graphed. And then I can tell that my graph is opening upwards. So I'm going to say that it opens up. Then I'm going to start off by identifying, I like to look at where the vertex is first. So I can see that the vertex is this lowest point right here. So I can tell first off that it is a min because it's my lowest point of my graph. And that point that I graphed was that point 0, 0. And I always like to use my table to make sure that I'm writing down the correct point when I write my vertex. Then I need to write the axis of symmetry. Now remember that axis of symmetry is the line that would cut straight through my graph and through my vertex and cut it perfectly symmetrical. So that is a vertical line that cuts straight through my vertex, and we're going to make it on our graph as a dotted line. Once you do that, we have to name what that line is. Whenever it's an axis of symmetry, it was a vertical line, so we're going to say y equals, and we cut through the 0 of our graph. So we're going to say x equals 0 as our axis of symmetry. Okay, let's try another example. Now we need to graph y equals 2x squared. So we're going to go back to our y equals on our calculator, and we want to type in 2x squared. So remember, your x is to the right of your green button, and then that squared is this button right here that has that x squared. So 2x squared is what we want. Now that we want to graph it, we're going to hit our graph button to see what we should have when we put it on our graph. And then if we want to see what those points are, we can hit second graph and look at all of those points. So they started me super far in the negatives. Your graph or your table may take you to a different spot, and that's okay. So let's write down our table on our notes. So we had our x and our y. So let's write down all the points we can possibly fit on a 10 by 10. And it looks like the first one we can fit is -2, +8, -1, +2, 0, 0, 1, 2, and 2, 8 are all the points we can possibly fit. So once you get those, let's graph. -2, +8, -1, +2, 0, 0, 1, 2, and 2, 8. So connect those dots once you have them all plotted. And it asks us to describe how this graph compares to the parent graph. So we need to tell what's the difference between this last graph that we graphed and this graph that we're now graphing. And I can tell just by the shape of it, it still opens up, but it looks like my graph got a lot skinnier. It was originally at a lot wider, but it got narrower. So I can tell that the only difference that changed in my equation was that 2. Originally we graphed an x squared. Now we graphed a 2x squared. So it looks like that 2 made the difference of making my graph narrower, or we could also say skinnier. Okay, let's try another one. Now we want to graph 1/2 x squared. Okay, so we're going to go in our calculators back to y equals, and now we have to type in a fraction. So whenever I type in a fraction, I have to make sure that it's in parentheses. So parentheses 1 divided by 2, and close that parentheses, and then x squared. Once we have that in our y equals, we're going to look at what our graph should look like. Then we're going to go to our table and hit second graph. So we do have some decimals on this one. So what I'm going to do is I'm only really going to graph the whole points, and that's okay. But I'm still going to only graph the ones that will fit on a 10 by 10. So the first whole one that I can fit on a 10 by 10 is -4, +8. I could fit -3, 4.5, but I'm not going to graph decimals. -2, +2 I can fit. Got another decimal, so I'm going to skip that one. 0, 0 I can fit. Another decimal I'll skip over, and I'll go to +2, +2. Skip over that decimal, and 4, 8 looks like the last one that will fit. So I'm going to graph all of these points on my graph. -4, 8, -2, 2, 0, 0, +2, +2, and 4, 8. So once you get all of those graphed, connect your dots, and we want to compare to the parent function. So let's look back at the very original graph that we graphed, which was this one. So originally we had -3, 9, -2, 4. It looks like our graph got wider. It still opens up, but our graph got wider. So it looks like since we had that change of now a 1/2, that 1/2 in front made our graph get wider. Okay, let's look at one more example. -2x squared. So let's go back to our y equals, and let's type in a negative, not a minus, 2x squared. So once you have that into your calculator, we're going to hit graph to see what our graph looks like, and I can tell that my graph flipped upside down. So we already know that 2, we talked about, makes that difference of making it skinnier or narrower. But now that negative looks like it's flipping our graph upside down. So let's go to our table and hit second graph. And we're going to write down all of the points we possibly can write. So it looks like our first one we can fit is -2, -8, -1, -2, 0, 0, +1, -2, and +2, -8. So once you got all those, let's plot them. Okay, once you got them all graphed, connect your dots. And so we can now see that it's opening down. And it's skinnier. Remember that 2 made it skinnier compared to our original parent function. So that negative flips our graph upside down, and the 2 makes it skinnier.